Okay, Assalamualaikum, and uh, we meet again. So this is the lesson for analysis of boost DC-DC converter. So due to its name, boost, so meaning that it can boost the input voltage into a higher output voltage. Okay, so the relationship in the theory, the relationship between the voltage output and the input can be written as V out is equal to VDC over 1 minus D, and D, I would like to record, is actually a duty cycle, which is the ratio between T on over T. Okay, so based on the theory, if the maximum D is 1, so meaning that when D is 1, so you will have your V out is infinity, and when D is minimum 0, you will have that your V out is equal to the input voltage, VDC. But this is not, in practical, this cannot be achieved. Okay, so in practical, there is some limitation, so this is not achievable. Okay, so we do the analysis to get the relationship between V out and VDC for the boost converter. So as it's actually similar to the buck converter, where we need to analyze the circuit in two conditions. The first condition is when the switch is on, and the next condition is when the switch is off. So we start with the switch on. So what happened to the circuit when the switch is on? So meaning that this switch is closed. So when this switch is closed, this node will become 0 voltage, and this node is actually a V out. Definitely, the diode will be reverse bias, so meaning that it is off. So which means that the current will always freewheeling, is actually not freewheeling, it will be rotating inside this circuit. So the KVL for the switch on, during the switch on, can be simply written as a negative VDC plus VL is equal to 0, and we already know that to write again, this is will be simply like a VDC. Okay, and we know that the IDT is actually delta IL, and the change of T is actually during turn on. Okay, so this one will be VDC over L. So finally, the change of IL during switch on is VDC over L multiplied with DT. Okay, because delta T on is actually a DT. Okay, so this is the equation that the important equation that we derive from the switch on. And then this, okay, and then next is actually the analysis during switch off. So what happened during switch off? So during switch off, okay, the switch is open, so the current will flow from the input to the inductor, diode, and capacitor, and also the resistor. So the KVL we can draw like this. Okay, the KVL during switch off is negative Vs plus VL, sorry, not Vs, is actually VDC. So sorry. So VDC plus VL, and we assume that the voltage across is 0. So just equal to V out. Finally, we'll have my VL is equal to VDC minus V out, and we know that VL is LDIDT, so we just put here delta IL during off, delta IL T off. So this one will be VDC minus V out over L. Okay, and we know that D off is actually 1 minus D. Okay, so delta IL during off is actually VDC minus V out over L multiplied with 1 minus D. Okay, so and then what's next is actually okay, steady sorry, I think okay, in steady state, delta IL on should equal to the change of delta IL during off. So meaning that delta IL on minus delta IL off should be equal to 0. So delta IL on is actually okay, VDC over L dt minus VDC minus V out over L 1 minus D equal to 0. So we simplify this, we solve this, we finally got that the relationship between V out and VDC is equal to 1 minus D, or sometimes we write down as a 1 minus D VDC. Okay, so that's all for the analysis on the circuit to derive the equation between input and also the output.